Okay, and here's a favourite question, often you see it in exams. A couple of reasons why it's a favourite. The first one is that the cosh, the curve that a naturally hanging cable will form, so it's a power line type cable. So the curve here looks basically like that. So it's the curve that a hanging cable falls in. And the second thing is it works out quite nice algebraically. So basically, to solve this thing, we're going to use the same formula we used on the previous example. So there's our formula there. So the first thing we need is we need dy by dx to bung it into the formula. So if y equals 10 cosh x upon 10, then dy by dx, to differentiate this thing, if you differentiate a cosh, you get a sine h. So it's going to be sine h x upon 10, and the 10 at the front disappears because the chain rule says you multiply it by a tenth, so that goes away. So we just end up with this thing here. So our curve is the integral, in this case from -1 to 2 of the square root of 1 plus dy by dx squared dx. Okay, and here's the nice algebra. If you look up on your formula sheets, you'll see that 1 plus sine h squared is just the same as cosh h squared, so it's back to cosh squared x upon 10, and then the square root and the square undo each other, so we just deal with the integral from -1 to 2 of cosh x upon 10 dx. Okay, so as you can see, it comes out quite nicely in the algebra. So now we just have to integrate this thing. So when you integrate cosh, you get sine h, and then we're going to have to deal with that 1/10, so we're going to need a 10 out the front of it. From -1 to 2, and we can just stick the limits in, so it leaves a 10 out the front of the whole thing. So we get sine h 2 over 10 minus sine h -1 over 10, and that you can just whack into a calculator, and the answer comes out to be 3.01. Okay, so the length of the curve between -1 and 2, this length in here for this particular function, is 3.01, which clearly shows it's rather flat at that point because the straight line distance is 3, so it's only just a little bit larger than that. So this curve between those 2 points is quite a flat curve.